This satellite view of Earth at night highlights a planet active with technology, continuously radiating radio signals out into the dark. Moving away from our world, we find that the Milky Way galaxy alone contains roughly 100 billion stars. This data visualization charts the expected number of habitable worlds. When we account for the trillions of galaxies in the observable universe, the presence of Earth-like planets becomes a statistical certainty. Based on these figures, the universe should be populated by a vast number of advanced civilizations. The math creates a clear expectation for cosmic neighbors. Their absence is an anomaly that suggests our models for how life develops across the stars are missing a key component. In 1950, physicist Enrico Fermi questioned the lack of evidence for these civilizations with a simple prompt: where is everyone? To find an answer, we have built massive infrastructure like this radio telescope, spending decades scanning the sky for any sign of a non-human signal. Searches have returned no confirmed messages, no sightings of megastructures, and no evidence of interstellar travel. Despite the sensitivity of our instruments, the surrounding cosmos remains quiet. This result contradicts our probability models, indicating a missing variable in our understanding of how civilizations evolve. One possible explanation involves the timeline of the universe itself. This timeline spans 13.8 billion years. For billions of years after the Big Bang, conditions were too volatile for rocky planets and stable stars to form. Humanity appears at the very end of this scale, occupying only a microscopic fraction of the final second. If the evolution of intelligence requires these specific cosmic conditions, it is possible that humanity is among the first civilizations to ever emerge. A different hypothesis suggests that while life may be common, its ability to survive long enough to travel between stars is rare. The Great Filter is a theoretical barrier, an evolutionary or technological dead end that prevents civilizations from expanding into the galaxy. This filter could take the form of nuclear war, environmental collapse, or the unintended consequences of high-level artificial intelligence. This poses a question for our own species. Has humanity already cleared this hurdle, or does the filter lie in our immediate future? From this perspective, the silence of the cosmos suggests that advanced technology may be inherently self-destructive. The silence may also be a result of the tools we use to listen. Older civilizations might communicate using physics or methods that are completely undetectable to our current radio wave technology. We could be living in a universe full of activity, yet we lack the necessary sensors to translate the signals around us. Inspiring, resolute. Even without an answer, we continue to look. These technicians working on an early satellite represent a persistent human effort to reach out and find others. The search eventually leads us back to our own perspective, standing on the ground and looking up at the night sky.